Welcome to another episode of Does It. Today we're with Tom from Westfall Aviation out of Arkansas, and we're going to be talking about my favorite civilian aircraft of all time, the Staggerwing. Tom, thanks for showing us this airplane.
You bet.
You've done a lot of work to this airplane.
We've done a little bit of work to this airplane. It took about a total of 8 years, not solid work, but it was in our shop for about 8 years.
But it paid off.
What
happened at EAA Oshkosh last year?
Well, we happened to win grand champion at EAA, got a gold Lindy out of it, so that was quite an experience.
That is a big deal. That is a big deal. Congratulations. Thank you for showing us this. This is such an iconic aircraft. I mean, the wings, the biplane with the top one a little further back than the forward one, it is just so beautiful. Tell me about this airplane. When did they start building the Staggerwing?
So this particular aircraft is a 1939 Beechcraft Staggerwing. It's a D17S model. It's got the Pratt Whitney 985 9-cylinder engine on the front.
How many horsepower is that?
It's a 450 horsepower at peak manifold pressure. So it's a very well-known and proven engine. There's a lot of those engines that were produced. They were produced before World War II, after World War II, and they're in use in many airplanes to this day.
And what was the vision for the Staggerwing? Why did they make the Staggerwing aircraft?
So one of the reasons, it was a marketing thing. One of the engineers that was involved with Beechcraft was a man by the name of Ted Wells. And Ted Wells was a very, very brilliant engineer. And one of the things that they wanted to do when they were designing the airplane is to have something that was a little different than everything else. But what they found when they did what's called negative stagger on the wings is they found that it gives you better visibility out of the cockpit. You don't have a wing obscuring your visibility up and to the sides. So that was one of the benefits of it. It doesn't necessarily fly any different than a regular biplane would fly, like a Stearman or something like that, or a Waco, but it looks different. So kind of like a Corvette or like the Beechcraft, the Dukes and stuff like that. They look like they're going 100 miles an hour when they're sitting still on the ground.
It absolutely does, but it's a very large cabin. Why did they design the cabin the way they did?
Well, this airplane is actually classified as a 5-person aircraft. So there's 3 seat belts in the back, 2 in the front, obviously with the 2 seats. People in 1939 weren't quite the size that we are today, so it's a really comfortable 4-seat airplane. But you can haul 5 people and you can haul baggage with this aircraft. So it's a very roomy, and it was more of a executive type of aircraft when it was designed.
Exactly. This was the private jet of the 1930s.
Absolutely.
Absolutely. Well, let's take a look at it up close.
Sure, let's do it.
All right, so as an Oshkosh Grand Champion, details are very important. I love this engine. It is so clean. How is it to keep clean?
Worked very hard to keep this one dry, seals and stuff. So when we were doing the restoration of this aircraft, this engine was off. The engine had only about 60 hours on it since major, so we didn't have to overhaul the engine, but we did preserve it while the aircraft was down for restoration. So we had preservatives in it and stuff like that, so it wouldn't rust up internally or cause damage internally. But the engine, they do leak, they do seep, but it's like anything else. It requires maintenance and a little bit of upkeep and a lot of wiping. You know, there's some times that you just get in here and you just wipe the dirt because the oil and stuff like that, it happens. It's just part of it. But they're a really neat engine. They sound like a pack of Harleys going by when you hear them go.
It sounds beautiful.
Yeah.
9 cylinders?
9 cylinders, 985 cubic inches.
Wow.
So yeah.
That's great. Now, 1930s technology. This is a constant speed prop, which means that the prop blade actually adjusts and it will change the bite that is taking out of it. This setup is beautiful though. What is happening here?
Well, this is a Hamilton standard propeller. It is a constant speed propeller. And the way this works is it uses oil pressure from the engine that comes through the crankshaft on this engine. The thing that's holding the propeller on is hollow. And pressure comes through that, it comes into this dome, and this dome will slide in and out depending upon how the blades twist. So it's biting more or less air. It's either coarse pitch or fine pitch depending upon where you push the lever in flight. For takeoff, you want it to bite a lot of air, so it's coarse pitch. When you're in cruise, you want to get more performance, more RPMs with less fuel burn, less manifold pressure, so it's going to go to a flatter pitch and give you the performance. So these are counterweights, and these counterweights centrifugally go and they help pull this blade out, there's a lot of mass here when you add centrifugal force and G-forces and this thing's spinning. These help make the blades turn and have different pitches, whatever you input with the control in the cockpit.
I love it. This is how most constant speed props work. It just doesn't have something that's as visible here.
Yeah.
It's normally hidden underneath a spinner.
A lot of aircraft have spinners. The one next to us has a spinner on it, and the spinners give it a little bit of a dress up. However, in 1939, most of these airplanes didn't have spinners on them. Number one, they were an added expense, so a lot of times the customers buying these airplanes in the 30s didn't want that added expense. The other thing was, it was harder to do maintenance because you couldn't get to your grease fittings and be able to see what was going on with your propeller. So a lot of these aircraft, when you look at the vintage photos of these airplanes, a lot of them didn't have spinners for those reasons.
What about this sticker right here? This is a beautiful sticker. It doesn't look like the ones I see nowadays.
So it's not a vinyl decal. This one's upside down. This one, so they're on the same way on both blades, but it gives the name of the propeller. It's a Hamilton standard propeller, and this is actually a water transfer decal. Like when you build a model and you put your decals on a model soaking them in water, well, that's how you put these decals on. And then they've got a varnish, clear coat over the top of them to help them stay on there and not go away. This is actually how the logo would have looked for Hamilton Standard in 1939. They changed their logo, and actually they changed their locations in Connecticut where they were built, so some of the later decals reflect that change. But for this aircraft, this is the correct decal that would have been on this airplane.
Beautiful propeller. I do have a question about the landing gear.
Sure.
These tires look a little different. You don't see these treads a whole lot. Where did you get these?
Those tires are actually the size is a 750 by 10. They're actually a Goodyear brand tire, and those are original type tires that would have been on this aircraft. Now, you can't go out and buy those tires anymore because sometime, I think it was in the 70s, the mold that made these tires, they were transporting it through the warehouse and it fell off the forklift and broke. Well, they didn't sell enough of them to justify making another mold. So these tires haven't been available from Goodyear since that time.
Wow.
So if you find new old stock ones or ones that are serviceable, you can have them recapped, and that's what we did. Wilkerson Tire and Rubber Company out of Virginia recapped these tires, and then they cut the diamond treads in them to make it look like it would have looked like in 39. That was a very common pattern. But the tire brands were Goodyear and Firestone. Yeah. General was a big tire brand, and their tread pattern had kind of what looked like a cloverleaf pattern on them. So the diamond treads were a little easier to have.
That's incredible. Now, retractable gear for a 1930s aircraft is not incredibly common. Obviously, they wanted speed, but what's kind of unique about this retractable gear?
So, yeah, you're right. Most aircraft back in that day, especially civilian aircraft, were fixed gear. They didn't move. They didn't go up and down and retract up into the airplane. So that was one of the things that these aircraft had early on, were retractable landing gear. The very first A model Staggerwings that came out, they had fixed landing gear pylons, and the wheels actually retracted up inside the pylons.
Oh, wow.
But
okay.
the gear didn't actually go up and down. Now these gear actually go up inside the belly, so they fold up towards the middle of the aircraft and they become flush with the bottom of the aircraft. So again, you have better aerodynamics and stuff like that.
Now some gear come up with hydraulic, some are electric, some are pneumatic. How do these gears come up?
So these gear are electrically operated.
Okay.
So there is a motor, an electric motor in this gear system that operates a chain and sprocket system. And that chain and sprocket are large, almost like a hay baler chain. It's like a bicycle chain, but bigger than a bicycle chain, maybe more like a motorcycle chain.
Right.
And so they ride on a carriage. So there's a slide tube that's behind this panel, and both sides have that tube. And as the motor pulls the gear away from 90 degrees like they are now, it starts traveling up that slide tube, and as it travels up that slide tube, they come up and they fold up inside. And then once it gets to the top of the slide tube, there's a switch, a limit switch, that shuts the motor off and lets them stay there. And then they stay there until when you're ready to land or come in for landing, you pull the gear handle down, push the gear handle down, and that reverses the motor and the gear come back down.
Bringing the gear up in this Staggerwing is one of the reasons why this is one of the most beautiful aircraft that's ever flown.
It was I don't know exactly if at the time civilian aircraft, if there were any other retractable civilian aircraft out there. I know Grumman had retractable landing gear in some of their military aircraft that retracted up into the fuselage, you know. But yeah, now you got into bigger aircraft, DC-3s,
right,
and bigger aircraft that had retractable landing gear. But for a business type aircraft or a civilian type aircraft, it was a pretty unique feature.
Were there a lot of gear up landings back in the day, I imagine?
There were a few. They actually demoed this type of aircraft, a Staggerwing. They put skids where the wing attach point is here.
Right.
They put wooden skids there, and they would actually shut the motor down in flight and come in dead stick with the gear up and demonstrate how crash worthy this aircraft was. So then they would jack the airplane up or hoist the airplane up, put the gear down, and they go demonstrate again how that would work.
Wow.
So there were, you know, gear accidents, and
right,
there are mechanical things that can go wrong with them, but it's a really robust system if it's well maintained.
All right, well, let's go take a look around.
Sure.
Structural integrity is really important, and there's a lot going on here, right? So you have this beam right here, which is connecting the top and bottom wing. What is that structure called?
It's called an I-beam because it looks like the letter I.
Yeah, and then in addition to that, you have these right here.
Yeah, so these are what's called flying and landing wires, depending upon how they're used on the aircraft. The ones that go one way are called flying wires, the other ones that go the other way are called landing wires. And what they do is they basically make a box section here that's a structural box section that stays true to its form under the stresses of flight. So you've got the box section here with the fuselage supporting the inside and the eye strut supporting the outside of the structure. And this little thing here is called a wire separator, or we call them birdies sometime. But this is a wire separator that keeps these wires in flight from humming around and bouncing. And there's quite a bit of tension on these wires. You have to tension these wires, and that keeps this box rigid.
Nice. Do they make a sound when it flies?
Yeah, sometimes they do. If they're not quite into the slipstream and you get a little hum or a little whistle out of them,
right,
that can happen. It doesn't hurt anything, but you try to get them, you know, parallel to the direction of flight. You want them into the wind.
Let's talk about the design. So I noticed the leading edge is firm, and then we have a fabric wing, fabric flight controls. What's on the leading edge?
So the leading edge is just a solid, either it will have a metal leading edge that's covered in fabric, or a wood leading edge. These aircraft are made with a lot of wood. So the structure of the wings and the flaps are on the lower surfaces, the ailerons are on the upper surfaces. And so what you have is you have ribs, the little ridges you see in between are called ribs, and those are made of wood. So those are laid up and glued, and they're a truss structure like a bridge. So those then maintain the shape of the airfoil of the aircraft. The covering, what was originally cotton covering, they used grade A cotton back in the 1930s and up until the 1970s. You could buy grade A cotton for covering aircraft. This is a modern Seconite process, so it's a synthetic fabric that is less susceptible to rot and deterioration.
It's pretty impressive to make this aircraft with literally wood and cotton.
It is. So people come up and they go, "Oh my goodness, that's not very safe." Well, aluminum aircraft don't have very thick skins either. Airliners, military aircraft, if they're not bulletproof, they're going to have because of weight.
Right.
So the fabric maintains the shape of the airfoil, and that's why we have what's called rib stitching that helps hold the fabric to the ribs so that they don't balloon up in flight. Because what makes an airplane fly?
It's the change of lift.
It's not money, but sometimes people say it's money, but it's your differential pressure.
Right.
The way the air flows over the top differently than the bottom creates lift.
Right.
It's a very narrow term, so. But so you want to maintain that airfoil, you want to maintain that shape, and that's what the rib stitches and the fabric maintain.
All right. Now this aircraft has a big wire that goes from the tail to the front.
That's for hanging laundry when you're camping. No, it's not. It's a radio antenna.
Yeah, I've seen that a lot on military aircraft, right? So this is for high frequency, ultra high frequencies.
Exactly.
This was originally on this aircraft?
So there would have been an antenna very, very similar to this antenna on this aircraft. Over the years, avionics evolved just like they do today, and old stuff goes away and the new stuff comes in. So that antenna is not original to this airplane, but it would have had an antenna like that on this aircraft.
All right, so we talked about this being like the private jet back in the day, but there was military uses to this.
Yes, on the onset of World War II, these aircraft that were owned by civilians, some of them were what was called impressed. The government said, hey, we need your airplane for military service. We'll take your airplane. If it survives the war, you can have it back after the war. Some of them survived, some of them didn't survive. And this aircraft would have been one of the type that would have been used for military service, either coastal patrol type airplanes, utility airplanes, transports between bases for personnel. You know, if there's a meeting at one base, they have to get the ranking officers to that base. This would have been a transport aircraft that they could have hopped in and gone.
Now, I'm not familiar. Was there a military designation for this aircraft?
There were. So the Army and the Navy both had this type of aircraft in service, and the Army aircraft were called UCs, and the Navy aircraft were called GBs. Okay. So they had numbers designating what they were after the GB or the UC, but the Air Force or the Army used them, and the Navy used them as well. And they were painted green for Army or silver, and the Navy usually were blue.
Great. And we talked about the front gear, how it retracts. This tail wheel retracts as well, correct?
It does. So all three landing gear on this aircraft retract. Again, just a unique feature that just helps in speed and aerodynamics.
Well, that's an incredible decrease of drag, especially for the time. How was this as far as speed goes for its time?
It was one of the faster airplanes of its time. When they were first designed in the 30s, this aircraft was faster than most of the fighter aircraft of the time. Now, fighter aircraft developed obviously and got faster and faster, but this was a very high performance, very fast aircraft for the time. And today it's still a viable airplane. You can bring the power back on it, and you can cruise with this aircraft at about the same speed you would in, say, a Cessna 182 or something like that today. So you can cruise 140 knots, you know, in flight still to this day in this aircraft.
So when I've flown aircraft in the past and I've had flares, I've used them to defeat infrared missiles.
Yeah.
These have flares on them, used for a very different purpose.
No infrared missiles back in 1939. Yeah, these ports here are what were called emergency parachute flares or landing flares. A lot of times back in the 1930s, airports may have had a beacon, but they never had runway lights. They were usually fields or grass strips, so they were very
dark.
They were very dark. So the procedure for using these flares, because if you're flying passengers or something like that for hire, this was a requirement by the CAA, which was the predecessor or the forerunner to the FAA. And so these flares actually have a tube inside, and that tube has a firework, a pyrotechnic in it. And that firework, when you hit a button inside, that firework shoots out and it lights another tube, and inside that tube is about a 10-foot diameter silk parachute.
Wow.
That hangs down below a steel cable. There's a phosphorus flare that lights up, and so that phosphorus flare is really bright. And so if you're coming, you find the airport and you fly over the field of the airport, you shoot that flare, say 1,500 feet above the ground, it burns for a minute and a half, so it floats down. It gives you an idea to see where you're at on the field. You can orient yourself for a base to downwind, or downwind to base. And then when you get on base to final, you could shoot the other flare at 800 foot, and that would kind of light up behind you as you're coming around on final. Now this does have landing lights on it, okay, but the landing lights were pretty ineffective for the time, so you had to be close to the ground. So that second flare would help kind of light up behind you as you turn, and then your landing lights would take over and you land. The third one was in case one of those two didn't work.
That's incredible. That's how it was used to recover. You had to bring your own pyrotechnics to be able to see the runway. And I love how when you said that, I don't know if you noticed it, you said, if you find the runway, you can use these flares.
Navigation was a little different than today.
Such an incredible thing. And this is a certified airplane.
This is a certified aircraft. They were certified. And to be honest with you, these aircraft, even to this day, have very, very few airworthiness directives, things that needed to be corrected that the FAA says you have to fix.
Right, I love it. And you found some original parachutes.
Sarah did, my wife did actually. I think she found them on eBay maybe. Okay. We called a guy that had some. We were looking for some. So again, this was a disposable item. So once these shot out, it shot this little cap off and there was just a hole there. And so you took that inner tube out and you threw it away, and the maintenance shop or your mechanic, they ordered them probably through the mail, a new system. They'd slide the new system in, hook up the wire in the back, and so it was a disposable system. And they're heavy. They weigh about 5 pounds a piece.
Wow, okay.
So they're very heavy. So when they weren't needed, people got rid of those to get rid of the weight. So Sarah found a person that had 3 of these, and she said, well, that'd be great. And he's like, I don't know how I'm gonna mail them to you. And she's like, what do you mean? She said, I think they still have stuff in them.
Oh, no.
I'm like, yep, don't mail them. So I had a friend fly over to this place, and actually he put them in an ammo can.
Okay.
And brought them back. But they were pretty inert. I mean,
but
they were dated 1936.
Are these still alive, or
No. So what we did, we hooked up the whole system, no power to it or anything like that. So the switches, the wiring, the rack, everything is in this system except for the flares that are inside. So we've got the outer tube that the flare would have shot out, but we don't have any of the flare system in there.
Now the parachute was signed very special, wasn't it?
Well, one of the things we found out when I deactivated these flares and took the candle and took the stuff out of them, I was looking at the parachute, and again, it's a silk parachute. Well, there's a place where silk was made. There was a stamp on where the strings of the parachute had that said "Made in Japan." So 1936, dated, made in Japan.
Pearl Harbor wasn't much longer after that.
They weren't really kind of our friends at that time period. But it was neat to see that the International Parachute Flare and Signal Company that made this system were buying their silk and buying their parachutes from Japan, which was a supplier of silk.
Wow. Let's go take a look inside.
You bet, let's do it.
Honestly, I don't even know where to start. This is absolutely immaculate. It's gorgeous in here.
Well, it looks like 1939, doesn't it?
Oh my gosh, it's so pretty. These windows, the way they roll. That is so cool.
So back in the 1930s and before, automotive technology was new.
Right,
You know,
yeah.
cutting edge automotive technology. And they did a lot of stuff at the Beechcraft factory utilizing automotive things. So for example, the window cranks and the window handles are Hudson Terraplane. So the Hudson Car Company provided the crank handles, like this trim crank handle, and the door handle and stuff like that. There's also some Ford parts in here. There's also some Chevrolet parts in here. So they utilized automotive technology even in aircraft back in the 1930s.
To be completely honest, I wish that aviation utilized the advances in automotive technology that we have today.
That's one of the great things about the experimental aircraft market, because you can have a lot more leeway in using more modern technology.
But the fact that this was a certified aircraft, it's a beautiful aircraft, and was able to utilize that technology, it's just so great. I love this right here.
So
let's walk through it and kind of talk about it. So we have a compass up here.
Have a whiskey compass up there, so it's a liquid-filled magnetic compass.
Yep.
That would have been standard.
This is the propeller control?
That's the lever that actually helps you control the propeller, the pitch of the propeller.
So this puts the oil up front to change, just like, this is the blue knob.
It changes a lever on the propeller governor.
Yeah, this for everybody who's flown at constant speed, this is that blue knob.
That's the blue knob.
Exactly.
Yep.
We've got the throttle here.
Yep, throttle right in the middle.
Okay, that's your red knob.
Yep, that's the red knob.
Your mixture.
Got the mixture right below that. Yeah.
Wow.
So it's not exactly what we like to see in a modern aircraft as far as a setup goes. It was a little different, you know, back then.
But it was new.
But it worked.
There was no industry standard back at that time.
Exactly. And flying this aircraft, you don't really realize it just feels right.
Yeah.
It feels like it's been there for 83 years now.
It's amazing. So I have a 1961 Debonair, Beechcraft, right? Same company. And it's amazing the difference in 30 years. Whereas if you go look at the brand new G36, it doesn't look that much different than my 1961 Debonair. This is just such a different time period.
Well, you got to remember, these aircraft were they were handmade.
Right.
There was production practices used. There was things like that they used to build these aircraft efficiently. But when it came down to fit and finish and actually putting stuff together, it was all done manually. It was all done by hand. So there's something to be said about the craftsmanship and the workmanship that goes into these aircraft.
All right, let's keep working around. We've got the much required ashtray.
All four places have an ashtray, so the kids can smoke. The people, everybody's smoking.
It was a different time.
A little different time back then. Yeah.
Okay, what's this knob here on the left?
So on the left, there's a big crank handle, and that is in case your electric motor stops working for your landing gear. You can crank your landing gear up or down.
So you have direct control of that chain that we were talking about.
Exactly.
Got it.
That is hooked directly down to the landing gear motor sprocket, and you can
electric landing gear handles right here.
Yep, and you would flip that up or flip that down depending upon which way you wanted to go.
A lot of the other instruments look like a standard 6-pack. The layout is a little different than maybe we're used to. So you got a fuel gauge here, airspeed indication. I assume that's miles per hour.
It is.
Turn slip indicator. You've got a very important clock.
You got a wind-up clock.
Well, and I don't think people understand. Now that we have the day of Stratus pucks and ADS-B and
cell phones
and 4-flight. That clock is incredibly important.
That is as much of an important instrument as your fuel gauge is.
Absolutely.
That is your fuel gauge.
It's your fuel gauge, it's your navigation, it's everything back in the day. Okay, a standard VVI, climb dive. You've got your altitude. Another compass here.
Yep, vacuum. So there's a vacuum system on this aircraft.
So you've got a wet compass, you've got a vacuum compass. It looks like an ADI.
Yeah, but it's artificial horizon. Yep, your horizon.
That's a very basic one. Is there a up and down, blue and black?
No, there's not. It's either going to work or it's not going to work.
Okay.
Vacuum operated.
Driven?
Yeah.
Okay.
Yep.
Is this the push to talk for the comp?
So that is, and that push to talk button is actually a doorbell button. That doorbell button.
It does look like doorbell.
There is a part number in the blueprints when they made this aircraft that gives a number. You can buy from the same company that doorbell button, and it has the same part number that's in the original blueprints.
You know, it's a low voltage button. Why not use it? Wow.
Yep.
Okay. As we work down, telephone.
So again, you had
both range.
So you had your modern radios in this aircraft.
Right.
They were you had a receiver and a transmitter. Those were your radios. So in these aircraft, when you navigated, you could navigate by radio signals and triangulation. So you could switch range or telephone. Now telephone doesn't mean make a phone call.
Right.
Telephone is part of the navigation system that you could do. You could switch between a range or a telephone range, and that would give you, or you could do both, so the switch says both. Now that switch doesn't work anymore, except I have it wired up to where it will work the original rare earth compass that has been in this aircraft. So it has the whiskey compass, it's got the vacuum compass.
Yeah, we've talked about these two.
But it also has a rare earth compass.
Is that this right here?
No, it's in the lower left of the co-pilot's panel. So it looks like a compass. It's got your cardinal headings on it and your degrees. So the lower left.
This right here.
Gauge is an original gauge that's been in this aircraft since it was built. And it's still in the same position it was in when the aircraft was built. And the aircraft, that gauge still works.
You say rare earth compass.
So magnetic. So it's got rare earth magnets back in the back in a sphere that houses those, and it's up in an area that doesn't interfere with the structure of the airframe. So and that sends a wire up electrically to that, and that will read your compass. So again, it's another navigational tool.
This is an IFR aircraft?
Yeah, this is an IFR aircraft.
Where's the second ADI?
Well, the rules were a little bit different back then.
I mean, I understand you have a wet compass, you have a vacuum compass, and you have a rare earth compass. That's great. You know which direction you're going. But knowing which way is up and down in the clouds
is kind of important. And those instruments weren't all that reliable. They had their issues. So I would probably rather be a light IFR guy in this thing, not a hard IFR.
Okay, RCA. I think many kids these days probably don't know about RCA, the RCA dog. Sitting in front of the telephone with the head cocked to the side. This is a radio. There's only two frequencies. Yeah,
so you have a receiver and a transmitter. So the transmitter is on, I can't remember what side. The transmitter's on the left and the receiver's on the right. So you transmit on one radio and receive on another radio. And yeah, there's only two frequencies because that's all there was. In 1939, you had tower and you had ground.
Across the entire country?
No matter what airport you were going to, you had tower and ground, and they were the same frequencies. Airports were pretty far apart.
As many times as I made radio calls on the wrong frequency, that'd be nice to have.
It would simplify things, wouldn't it? Yeah.
Okay, great. And then this right here, this looks like this reminds me of like the old school radios that you have to spin the dial to get to a specific frequency.
Like a coffee can, you know, coffee grinder type thing.
What is this?
So because the instrument panel is close to the firewall, radios back then were huge. They had tube radios, they had big boxes, they were clunky, they were great big pieces of equipment. That was actually just the control head on the panel, and all the tubes and the radio stuff are in the back. So there was a cable that ran that crank, and when you turn that crank, that cable would turn, and it would go all the way back here to the back, and as it turned, it would change the length in the box, which would actually change what frequencies you're on. So you have your frequency ranges on that instrument, but that's how you would actually change your frequency. So you'd dial them in, and you'd get that whistle, that noise, that old radios made when you were going through the frequencies.
That's great. Now, I haven't seen, but I've heard there is a very special Easter egg up here.
There is an Easter egg. So again, this aircraft has all the original steam gauges, the analog gauges, and they do work. So your manifold, your RPM, your airspeed, all those gauges work, with the exception of just a couple of them that are just there because they would have been in the airplane, but they aren't needed anymore. So what I was able to do was, where those radios, those old radios you're looking at, those are actually fake panels. And so when you fly this aircraft, you unscrew those fake panels, put them in a bag. Yeah, those 2 panels are fake. Underneath those panels are the modern radios. We have a trig transponder and a trig radio, comm radio. We have a JPI 850 engine data monitor, so we can see all digital fuel flows, EGTs, CHTs, everything going on with the engine. So it's a redundant digital system to the analog system. And then we've got our intercom system underneath the other radio, and then we've got some modern circuit breakers and stuff that are hidden behind there as well, because they used glass fuses back in 1930s.
Wow! So keep the look of the original, but
we wanted to maintain as true to 1939 as the way it would have looked back then. And one of the things, we were talking about automotive technology. All the glass in this airplane, all the windows, including the windshield, are actually glass, and they're safety glass. So again, automotive technology was cutting edge, and safety glass was something that every automobile would have had in it. And so this aircraft has actual glass windows, windshield, that are actually safety glass windows.
Your gear indication, these crystal lights right here?
Yep, there's 2 big lights right there. You've got a green and a red. Green is good, the gear is down. Red is the gear is up and you're flying.
And neither is, it's not,
that's correct.
It's also not good.
Correct, and there's a placard right there in the middle that tells you about the gear operation.
I was looking at that. God, I just love the look of this. It's getting a little warm in here though. You ready to get out?
Let's hop out and get in the breeze.
All right. Well, Son of Fun is wrapping up. I know y'all got to get out of here. Thank you so much for showing this beautiful piece of history, beautiful airplane, the most beautiful Staggerwing I've ever seen.
Glad to tell you a little bit about it. Come and see me. We'll talk about it some more sometime.
We're not too far away. I'd love to see this thing flying.
Sounds great. The owner, Mark's here, and he's getting ready to blast off, so maybe you can see the startup.
All right. Y'all fly safe.
All right. Thank you.